About arithmetic and geometric sequences. So first, to begin with arithmetic sequence, it's a sequence of constant addition or subtraction, such as over here 4, 7, 10, 13, 16 are constantly added by 3, and for 5, 4, 3, 2, 1 they are consistently subtracted by 1. And this formula looks like an equal a1 plus n1 times d, which the n represents the number of sequence and the d represents constant difference. Sum of arithmetic. It's a sum of all terms of an arithmetic sequence, and all infinite arithmetic series are diverged. And over here, when we put s as an series and let the common difference be d, and then we can write s in two ways, which first one is this one and the other one's this one. And by adding these two equations and canceling all those terms involving d, we get the equation of 2s equal a1 plus an, a1 plus an, and keep going, and it will become n times n, a1 plus an. And so the sum becomes s equal n times a1 plus an over 2. A arithmetic sequence example problem, which is from AMC 12 2006, and here's the problem. A number of linked rings, each 1 centimeter thick, are hanging on the peg. The top ring has an outside diameter of 20 centimeter, and the outside diameter of each of the outer ring is 1 centimeter less than that of the ring above it. The bottom ring has an outside diameter of 3 centimeter. What is the distance in centimeter from the top of the top ring to the bottom of the bottom ring? So I'll give you a few minutes and pause the video to solve it. We have to use sum of arithmetic series, which to begin with, the inside diameter of the ring are at the most bottom it will be 1 centimeter, because when we take 3 minus 2 it's 1, and for the most top diameter the inner diameter will be 20 minus 2, so it's 18. So the inner diameter will be starting from 1 to 18, and the total distance needed is the sum of these values plus 2 for the top of the first ring and the bottom ring of the last ring. And using the formula of the sum of arithmetic series, it will be quite simple, which it will be just 18 times 19 divided by 2, and then we don't have to forget that we have to plus 2. So the answer will be 173. So the answer choice B will be the correct answer. Geometric sequence, and geometric sequence is simply multiplying with the same number, for instance, or dividing. And for instance, 3, 15, 75, 375 are all multiplied by 4, and 324, 108, 36, 12, and 4 are all divided by 3. And the sequence will look like this: an equal a1 times r, which represent ratio o with the square of n minus 1. Geometric series. It is a sum of all the terms of geometric sequence, and then they come into two varieties, both of which have their own formulas, finitely or infinitely many terms. And to talk about finite first, let the geometric series have value s, then it will look like s equal a1 plus a1 times r plus a1 times r squared. And factoring out a1 and multiply both sides by r minus 1, and using the difference of power factorization yields, you get a number like this: s times r minus 1 equals a1 times r minus 1 times 1 plus r squared plus blah blah blah, and then like this. And then dividing both sides by r minus 1 yields this equation, and this is a proof. And for the infinite geometric sequence, it converges if and only if r absolute value of r is smaller than 1, and if this condition is satisfied, the series converges into a1 over 1 minus r. And to prove this equation, it's using the same thing, s1 s equal a1 plus ar plus a1r square, and multiplying both sides by r and adding a1, we could find this equation over here. And then thus, when we calculate them, we'll get to this equation again. Sequence example problem, and it's a question from Amy 2005. And here's the question: an infinite geometric series has sum 2005, a new series obtained by squaring each term of the original series has 10 times the sum of the original series. The common ratio of the original series is m over n, where m and n are relatively prime integers. Find m plus n. And pause the video. You can pause the video and solve and come back again. To solve this problem, we will set the term of the original geometric series as a and the common ratio as r. So 2005 becomes a plus ar squared plus, and it continues. And using the sum formula for infinite geometric series over here, we have a over 1 minus r equal 2005. Then we'll form a new series, a squared plus a squared r squared plus a squared r squared r to the power of 4 plus it can continue on. We know this series has sum of 2000 and 20,050, which it will become a squared over 1 minus r squared. Dividing this equation by a over 1 minus r, we get 10 equal 1 plus r, a over 1 plus r. Then a will be equal to 2005 minus 2005r, and a also could be equal to 10 plus 10r. So when we substitute a a one so one equation to the other, it will become 2005 minus 2005r equal 10 plus 10r. So when we solve for r, it will become 2015r equal 1995. So r will be equal to 399 over 403. And then because we are finding the sum of m over n, the m will be 309 and n will be 403, and the sum of them are 802.